Hey, hello everybody. Good morning. Welcome to the Data Science Bootcamp. Sorry we started the meeting a little bit late. There was another meeting going on. We'll just give the other participants another 5 minutes for them to join, and then around 10 past 10, we'll kick off the meeting. Request all participants to mute themselves upon entry. And in case they have any questions, they can unmute themselves and ask the questions. Good morning, Ravi. Thank you for joining. Good morning, Arun. Thank you for joining, sir. So we'll wait for another 2 to 3 minutes for other folks to join in. Okay, everybody, let's get started. We have enough participants in the call. Sorry for the initial delay. There was another meeting going on, so we had to push this one back by a couple of minutes. But thank you, everybody, for waiting. Uh, Before we start, am I audible to everybody? First and foremost, a couple of things. Upon entry, please mute your microphones. You can unmute yourself and ask a question if you have one, but all during the other times, kindly keep your microphones on mute. Secondly, if you want to ask a question, you can simply unmute your microphone and ask, or you can use the chat option. I'll be monitoring the chat window throughout the meeting. You can use either of them to ask any questions. So before we begin, am I audible to everybody? And is my
Yes,
screen
Alexa, you are audible.
okay? Thank you. And my screen is visible, I believe.
Yeah, you have the data science bootcamp written, right? That screen is there.
Yes,
Yeah,
yes.
yeah.
Okay, okay. Thanks for confirming. Okay, so let's get started. First of all, a warm welcome to the Data Science Bootcamp hosted by Tamilboomi on July 13th and 14th. My name is Aritra Banerjee. I will be your host for the next couple of days for this particular bootcamp session. And together, we'll take a sneak peek into the world of data science, understand what data science is, how it is helping uh, businesses provide better results, provide customer ecstasy, and what uh, does a data scientist do on a day-to-day basis, what skill sets you require to become a data scientist, and what and why is data science currently the hottest job role in the market. So first and foremost, I thank every one of you who has joined for taking precious time off on your weekends to learn something new. I understand and I realize how precious our weekend times are when we are busy throughout the entire week, right? So I appreciate all of you for taking some time out of your weekend's schedule to join this meeting and to learn something new. So before I start, I'll give a brief background about myself. My name is Aritra Banerjee. I'm a data scientist. I have several years of experience working across different businesses for different various clients, working into analytics, providing or like looking into use cases, business problems, providing them with analytical solutions, and helping business gain a lift by leveraging my knowledge in data science. Uh, Moving on, the agenda for the next couple of days will be, so firstly on day one, which is today, we'll have an introduction to data science. We will try to understand how data is being generated, how much data is being generated, what kind of data is being generated, and from where data is generated. Now, next, we'll move on to how data is used on a day-to-day basis by these companies. What is data science and what is the life cycle of a data science project? And how a data scientist can enable business to take particular business decisions better and gain a competitive edge over the market. And also, to cap it off, we will try to understand who a data scientist is and what entails the data scientist's day-to-day activities. Right. Now, on day two, which is tomorrow, we will uh, look into few popular use cases of data sciences, how currently companies are using data science technologies, how they're leveraging the data science knowledge and insights, and how the data science has improved the ability of businesses to take important decisions. And also we will perform a hands-on practice session in which we will try to solve such a business use case by leveraging our knowledge in data science. Right. So before moving on, small request to everybody: please let the session be as interactive as possible. It should not be only me doing the talking. I encourage all of you to pitch in, join on the conversation, provide your inputs so that as a whole, our collective knowledge on the group can improve, right? I'll stop in between topics and have the floor open for any kind of discussions, any kind of questions. And you can, participants, you can direct the questions at me. I'll try to answer them to the best of my abilities, and then I'll open the floor for other folks to pitch in on the same question. So in that case, our collective knowledge will increase. Sounds good? Great. So let's move on. Let's start today's session, Data Science Bootcamp Day 1. We'll cover Introduction to Data Sciences. Now, the first topic that we will try to tackle over here is the origin of data. Now, where is and how is data being originated? Now, nowadays, data is everywhere. Just take a casual look around you and you will find several elements of data which can process and harbor data, starting from your smartphone, your laptops, your TV, newspaper, smart speaker, smart watches, everything. Nowadays, everything comes with a smart added before it, right? If it is not smart, we tend to ignore it, right? So everything around us is capable of holding, harboring, or generating some kind of data. But do you know that on a daily basis, over 2.5 quintillion bytes of data is generated per day? You may ask, how much is quintillion? So just a rough understanding, quintillion is 2.5, and after that there are 17 zeros. So that much data is generated per day by all the users, all the people on the entire earth. Now this will only increase. Now a survey or a report says that this data generation rate will rise to 1.7 megabytes of data per second per person by the year 2020. So by the time this time next year, a single person on earth will generate around 1.7 megabytes of data per second. Now we can only imagine the vast capabilities that will come along with it. Now, data nowadays comes in several forms, and we try to classify these data. We try to characterize rather these data by the 3 V's. The 3 V's of big data, as most of you are aware, they are volume, velocity, and variety. Now, as I told you, as I just gave an example of the volume of data that is generated per day, 2.5 quintillion bytes of data is generated per day. That's huge. And the velocity of it is also. So this much of data is coming in one single day. So that's a lot of data coming in a short span of time at a very high velocity. And the variety as well. Nowadays, data is not just restricted to our spreadsheets or our tables in our database. Like, it's not restricted to relational databases where we have several columns and we have several rows of data, right? No, we are not restricted. We have not restricted ourselves to only that. Nowadays, data comes in varied forms. It comes in structured forms like your spreadsheets, your tables in your database. It comes in semi-structured forms like your XML data, where we identify each data tab, each data element by a tag, a start of a tag and the end of a tag, and the element inside the tag is called the data value, right? So these are called semi-structured data. And data also comes in unstructured forms. Unstructured forms of data come in several examples like your images, your textual data, news feeds, and all these kind of data come in unstructured form. Funnily enough, the volume of unstructured data flowing in has bombasted over the last few years. It has overtaken the amount of structured and unstructured data combined that we currently have in the world, right? Now, how have we as human beings adapted to this outburst of data? Have we, from our end, done anything so that the data processing, or we can at least store and process this enormous volume of data? Yes, we have. We have brought in big data platforms. We have brought in systems which can harbor, which can store and process these huge volumes of data. We have Hadoop ecosystem, which gives us an excellent platform to store, process, and access structured, unstructured, and semi-structured data, and that too at a very high rate of efficiency, right? Okay, so moving on, how is data being generated on a day-to-day basis? Now, first and foremost, we as human beings, we as users, we we tend to generate data both consciously and unconsciously. Now we'll just take a look at few such examples of how actually we as users generate the data. First and foremost, we generate some data through our smartphones. Like smartphones have several apps which require permission to our personal data, right? There are several apps which will not even function properly, which will not even function to their full extent or full potential if you do not give them access to your personal data. Personal data like your contacts, your media information, your location, and whatnot, right? So that is how all these kinds of apps, they are collecting data from us. Secondly, we data is also being generated from our day-to-day activities. Like we go to Amazon, we have an Amazon app on all our phones, right? We go to Amazon, we buy something, that constitutes as an online activity. We get the receipt of the same through our email. Then we go somewhere, we click a photo. Say we go to some tourist place, we take a photo. This photo is saved into our phone, and you may opt to upload this photo to Facebook or to even Google Cloud Storage and whatnot, right? So all these by these small activities, we willingly or unwillingly generate some amount of data ourselves. Next, we have our laptops. We usually browse several websites. We usually do a few Google searches on our laptops. So nowadays, the use of laptops have been greatly reduced by because all these kind of activities that we previously used to do on our laptops are currently available on our phone. But still, some of us who are rustic, me for example, we prefer doing searches on our laptops because it's convenient for us, and thereby we generate some kind of data through web browsing, through the websites that we have visited, through the search keywords that we have used now in Google or Bing. We generate some amount of the data or the other. Next, we now have the concept of smart homes, right? Wherein we can control anything and everything in our homes using smart devices like Google Home speakers, Amazon Alexa speakers. They can control each and every item of our home, starting from locking the front door to unlocking it, switching on the lights, dimming the lights, switching on our TV, playing something on our TV through Amazon Fire Stick. Everything is connected through the Internet of Things, the IoT, as we better call it. Now, what kind of data is being generated through here, and what kind of data is being used here? First and foremost, our location is being used over here. Secondly, at what time are we in our house, or what time are we not in our house? This kind of data is being generated. What do we search for, or what kind of movies do we like and dislike? This data is also being generated. Next, moving on, we have again Nowadays our cars are even have turned into smart cars, right? You can control several aspects of your car from your a small app on your smartphone. Now what kind of data are you generating through this? Again, location data, where you have visited with your car, where how fast have you driven, which route do you take, at what time do you leave, at what time do you reach. All these kind of data are being gathered and stored through these smart cars. Last and not least, social media. Now, I don't even need to start on social media, right? Now, our entire lives can be deciphered through if we just analyze the data that we currently generate in social media, correct? So, because of that, I've dedicated an entire slide in which we will discuss exactly how much data we generate through social media platforms. What are the popular social media platforms that we use? There are several, right? Facebook, Twitter, Pinterest, Instagram, LinkedIn. I have just jotted down four of the top social media sites that we use on a day-to-day basis. And just a few insights I would like to share with you regarding how much data is actually being generated or processed through these social media platforms. Now, Facebook, for instance, there's over 2.5 billion contents per day that is generated on Facebook. Out of those, like around 2.7 billion likes and other actions, likes and dislikes or reaction actions are being recorded per day in Facebook. 300 million photos are being uploaded to Facebook on a daily basis. So all in all, over 500 plus TB of data is being generated by Facebook on a single day. That's enormous, right? Next, for Twitter, over 500 million tweets are generated on a single day in Twitter. Instagram, over 50 million of photos are uploaded on a single day by all the Instagram users. LinkedIn, around 120 million users usually access LinkedIn on a day in, day out basis. So this is huge, right? I just hope you can understand, you can rather appreciate the amount of data these companies are generating on a day-to-day basis. Now, what kind of data are these companies generally collecting from the users? Now, first and foremost, these users, these companies collect what our likes are and what our dislikes are. And for example, in Facebook, it collects data regarding our activities. Which kind of posts have we liked? Which kind of posts have we disliked? In which posts have we commented on something? And what kind of post have we shared, and so on. Next, it's these companies collect our location data, where we are exactly. So, as you know, must have seen a feature in Facebook wherein if somebody who is in your friend list is traveling to a place near you, you instantly get a message saying that okay, this person is nearby. So you can uh, ping him, or you can send him a message, or you can poke him or whatnot, right? So this kind of data is also collected from Facebook, our location data. Next, photos. Photos serve as a huge repository of data because whenever we go someplace or do something and we want to make it memorable, we take a photo, right? And nowadays with the digital age, we want to share that photo, we want to share that happiness with everybody, with all our friends, our real friends and our Facebook friends. So what we upload these photos to social media websites like Facebook, Instagram, and so on. Now, these photos also constitute a bit of our life, a bit of what we do, where we go, what kind of people we hang out with. Last but not the least, what do we search? What keywords do we use in our search? What all things we have in our search history? All these kind of things are also collected by these companies. Now, what is the point of these companies collecting these data now? Because as I just told you, Facebook generates over what 500 TB of data in a single day. Now it's a headache for them to simply store the data at their end, right? Then why would they go to this length, or why would they go through all the pain of collecting and storing the data? It must have some value of to them, right? Now I'll just give you a brief of how this data is actually being used by these companies, and not just these companies. How is this data, how is your activity on Facebook valuable to a company, say Amazon? I'll just give you a brief example. You must have noticed that you have this must have happened to you. So we say one day you visit the Amazon store, you open the Amazon app in your phone, and you check out a new camera, right? You've started a new hobby of photography and you want to buy a DSLR. So you go to Amazon, search for a entry level DSLR or whatnot, and then instead of buying one, you just add one to your cart and leave it there. Or maybe you don't even add one to your cart, you just go and visit, browse 2 or 3 different type of DSLR cameras, right? In a very short time, say within minutes, you log into Facebook, the Facebook app, or you say your Facebook through your browser, and instantly on the side of your screen you see advertisements for a different type of DSLR cameras, right? So how did this happen? This is not magic, right? Now, how did this happen? Basically, what happened is that Amazon stored your data on your recent activity, and then it shared that data with Facebook, saying that okay, this particular user, he or she is interested in buying a new DSLR, or interested in viewing a few different options of DSLR. And then when you go to Facebook, Amazon starts advertising. That okay, since you have not yet bought a DSLR, here are some other options you can also look at. Same thing when you go and search something in Google. Say you want to you want to go for a vacation, and so you search in Google saying that okay, Google, show me the top vacation spots or top party spots in say Spain, or say top places to party in say Goa. Let's be nearer to home. And then Google will throw up a bunch of search results, and you click on a couple of URLs, and say one of them is TripAdvisor, and you're done. You don't go any further. Again, when you log back into Facebook or you go to some other website, you'll see a tiny pop-up window or a tiny ad on your screen saying that okay, there are some other spots you can also look into. There are some other places of interest that you might be interested in, and just follow this link to go to TripAdvisor and continue your searches, right? So again, this is a classic example of data sharing between these huge platforms. Now, why do they do this, or how do we benefit that for companies like Google, companies like Facebook, Amazon, TripAdvisor, since they are saving our data, then they are going through such pains of saving a whole lot of data for us. How are we at the end benefiting from it? First and foremost, we are benefiting through these kind of advertisements which I just told you about, right? Whenever we search for something, we get through these advertisements, we get something better out of it, some better options, some different options which we had not looked into before. Next, we get personalized feed for us. For example, I believe all of you have Google News feed on your phones. Now you can see, you'll notice that through your search histories, through your browsing histories, these Google News feeds will change to align themselves to your likes and your dislikes. So what we get is we get a personalized feed of news, of information thrown at us by Google after analyzing our day-to-day activities, day-to-day browsing histories, day-to-day preferences, likes and dislikes. Right? We also get personalized and better search results if because these companies are storing and analyzing and processing our data. So before we move on to the next topic, I would like to throw the floor open for any questions. I see that we already have a question in our chat. If I have a account in social media websites like Facebook, now if I don't have account, is there still possible for them to have my data? Yeah, and it has been answered. Also, so Debaditya said that if you had one and deleted it, your still data will still be archived. Yes, that's right. So just my 2 pence on it. Yes, if you already had a social media platform and then you delete it, it doesn't get deleted immediately, right? They still have a lock-in period or some that varies from platform to platform, but they don't delete it at the outright. They archive it, and then there's an option for you to retrieve your account back, right? However, if you do not retrieve it within a certain span of time, say for 3 months or 6 months, then finally they will purge your data. Okay. So any other questions before we move on to the next section?
Hi, editor. Am I audible?
Yes.
This is Jishnu. So I have one question. Like for one of your previous instances where you told, like, say you have something in Google, and the same results can be repeated when we are logging through Facebook, like the vacation spots or whatever. So just to want to confirm, like, is this in this case, like, does Facebook actually buy the data from Google? Like, is there any payments happening between them?
Yes, good question. Yes, Facebook does buy the data. So
Okay.
maybe not directly from Google. So what happens over here is that there are several companies who actually scrape this kind of data uh, and collect this kind of
Okay.
data. So what happens is they have several robots, or in some instance, they actually go to Google and buy the data from themselves, or they scrape Google and gather some other kind of information, and then they mask this data to a certain extent. So, for example, uh, Facebook, when they are looking into your search history, they will try very hard to tie the data they have got from Google to your Facebook. So, and in certain instances, they are very good at tying your data from Google to your data from Facebook, right? But say for other companies who do not have your personal data at length, they will not be able to tie those data back that they have got bought from Google back to you. Does
Yeah.
that
Got it.
answer your
Yeah.
question?
Yeah.
Okay.
Thank you.
Okay. Any other questions? Anybody else? Or if anybody wants to shed some more light on Jishnu's question, please feel free.
I think Debaditya has one question. Okay, he has written what? Okay.
Okay. So his question is, I bought an oven from Amazon, and then all of my feeds are filled with oven ads, including Amazon's. So this is just forced advertisement in the name of convenience. Is this the pinnacle of data management, or is there a better way? And it's not implemented yet. So, Devaita, to answer your question, uh, this is yes, it is forced advertisement, and this is how the companies generate their revenue from, right? Facebook, as you know, it's free for you, right? It doesn't charge you a single penny to have an account on Facebook. So how will Facebook manage its business process? What is the business model of Facebook? Well, Facebook runs entirely on ads. All these companies, Facebook, Google, all these companies which do not charge you a single penny for having an account or using their products, run on their on ads. 80 to 90% of their revenue come from ads. So yes, they will run advertisements on their website, but you can very well reduce the number of advertisements that you see. There's an option that you will find on several apps like Facebook or Google or Amazon, by which you can turn off the data collection from your phone, right? You can choose not to share your search history or not to share any personal information with these apps. So what will happen is that you will reduce, if not remove, you will reduce, certainly see a reduced number of ads appearing uh, on your phone or on your devices. But still, there will be a little amount of a little number of ads that they will run, because basically they need to keep their revenue flowing in, right? And this is how they generate their revenue, through ads. That is a very good question, by the way. Okay. Anybody else has any questions before we move on to the next section? I'll just wait for a few seconds.
Hello.
Yeah. Hi.
Okay. Yeah. Hi. Myself Ganesh, and I have one question, bro.
Yeah. Tell me.
Yeah. I just brought a watch from Amazon. Okay.
Okay.
And then when I log in into the Google, I can see the advertisement there. So, can you have any idea that how they fastly transferring the things and all?
Sorry. Can you please repeat your question again? Idea regarding?
I just brought a watch from Amazon, bro. I just ordered a watch from Amazon, and while I'm logging into the Google, okay, I'm just seeing that advertisement of Amazon, that advertisement of watch from Amazon in Google page.
Okay.
So can you have any idea about that? How they are dealing with Google?
Yeah.
How they are giving that advertisement in Google?
Yeah. So as I told you, Google runs on ads, right?
Yeah.
What they do is basically they exchange their data, or they buy the data from each other. These large companies, they buy the data from each other. Or another thing, what they do is that they allow. What they do is they buy the data from each other, and then they try to link your data and try to build an ecosystem of data around you as a user. So, for example, you as a user have some digital footprints on Google, have some digital footprints on Amazon and Facebook, right?
Yeah.
So what Google will do is that Google has its own set of data regarding you. Google knows what you have been doing in Google. Google will buy data from Amazon and Facebook, and they will try to link your Amazon activities and your Facebook activities with your activities in Google, right?
Okay.
So as to build a kind of ecosystem of data around you, and then they will allow these companies like Amazon to run ads. So whenever you have logged into Google, whenever you are doing something, searching in something in Google, Google will allow Amazon ads to flow into your Google feed, and thereby Amazon and thereby Google will generate revenue. So Amazon will have to pay something to Google each time they show you an ad regarding an Amazon product when you are in Google.
Okay. Oh, that's why we are signing with Google, like Gmail. That's why they are asking Gmail to sign in, huh?
Exactly.
Oh, okay. Thanks.
Yeah. Okay. So, a lot of great questions and very good discussions we had. Look, let's move on to the next section of our discussion, that is data and how it's being used in businesses. Now, how is we have another question from Arun. Any common portal available to buy data? There are lots, Arun. There are several data which are free, mostly government websites. Like you'll find several government websites. Like for India, they have websites which end in gov.in, gov.in. They have websites from the US which end in gov.us, UK websites which end in gov.uk. So all these kind of websites, basically data.gov.in, data.gov.us, these are government data which are free to use for everybody. And also there are several vendors, as I told you just before in the discussion, there are several vendors who basically procure the data from several companies. So there's one vendor who buys data from over 400,000 mobile apps, Android apps, and uh, iOS apps. And what they do is that they process this data, and they sell they fine tune these data, mask the user information, and they sell these data to several companies. Now these app data basically they can be used in several different ways. They can be used in market research, they can be used in analyzing purchase behaviors, and so on. So depending upon the kind of data you want, there are several vendors who are currently doing this. Last question before we move on to the next section from Devaditya. What is the extent of this data that is shared between companies regarding the Facebook US election scandal? Okay, this is something which would require some serious discussion. So let's take this particular offline, because this again borders on some controversies. Let's not get into that right now. We'll take it offline, and I'll probably we'll discuss this in tomorrow's session, time permitting. Okay, moving on. How is data processing done in business? Now, data is in business. Every business has its own set of data, right? So, for example, if I am say a company like Apple or Samsung, I will have my own data generated in several ways. I will have data regarding purchases, I will have data regarding sales, I'll have data regarding inventory, and I will also have certain user level data. Now what I need to do is that as a business, I need to extract data, collate and extract data from all these sources. And then what I'll do is the next step of it is to transform the data. Transform to the data to the required need. So for example, say a particular receipt, it will have in the raw form, it will have several information, right? It will have a receipt number, receipt date, the items that are purchased, how many of them are purchased, from which store, who has purchased them, etc., etc. So in the raw form, it will have all these kind of data, but I might not need all the information of in the final end table, right? I might not need the date of receipt. I might not need the receipt number. So if I might tend to aggregate these kind of data and move on. So all these kind of transformations happen in the second layer, and then we load the final product, load the final data into our data warehouse or data lake. Now this is the classic scenario of what we call the ETL, extract, transform, load. Extracting, identifying the source of data, extracting the data in its raw form, transforming the data as per our business needs, and then loading the data to our data warehouse. Now this is what most businesses are doing right now with their data. Now, what do businesses gain by storing or by processing this amount of data? It's a major overhead to store and process data on a day in, day out basis. Now, the end product of ETL is a data warehouse now, or a data lake. Now, from a data warehouse or lake, businesses generate reports. Most of these reports are canned reports. So basically, they answer stuff like what happened, when it happened, how much of it has happened, and where it happened. So for example, I have data in my data warehouse. I have data related to my past sales. Say I'm Apple, and I have data in my data warehouse which pertain to how many iPhones I have sold in the past 5 years. So I know exactly the number of iPhone 8 sold in the last 1 month, the number of iPhone XS sold in the last 1 month, and the number of iPhone XRs sold in the last 1 month. And I also know where I have sold most of these phones. I have how much of their iPhones have I sold in the US, how much of the iPhones have I sold in Europe, and how much of iPhones have I sold in the Asia Pacific region. And also I know when have I sold, what is the time that over the past few years, at what time do my sales peak, at what time do my sales dip, and also what kind of users buy my phones, right? So basically we are describing the data that we already have, right? We basically try to draw insights of what already has happened. Now that is, and we tend to take business decisions based on historical trends, right? So this is what business intelligence helps us in doing. This is what a typical BI report or typical BI environment helps us in. It helps us analyze or describe what has happened, how it has happened, where it has happened, by how much and when, right? So small summary of what businesses are currently doing with the data. Now, moving on to the next topic, what is data science? Now, data science is basically an accumulation of scientific methods, an accumulation of business processes and algorithms to extract knowledge and insights from data. Now, I'll explain to you how data science helps us, how data science basically, from how it differs from business intelligence and how it helps a business do better. So for now, just try to understand that data science, let's try to remember this. The data science is basically an accumulation of methods, processes and algorithms by which we can extract knowledge and insights from data. Now, this is a classic example of how business intelligence and data science differ from each other. Now, there are, as you can see in the box, we have several aspects of knowledge. First aspect is that we know what we know. So for example, if I know that 2 plus 2 is equal to 4, so I know that, okay, I can do addition, right? Again, we know that what we don't know. So for example, I am very poor in biology. I have no idea about the human physiology, right? So I know that, okay, human physiology is alien to me. I don't know a thing about it. But the most important thing is that, do I know what I know? So for example, I have taken the example of Apple. Apple has sales data for iPhones from the last, say, 5 years. Does Apple know how to use it apart from describing what has already happened? What has already happened in the past? Does Apple know how it can use this data to generate some other insights? So basically, Apple describing its data through BI would fall under the category of you know what you know. So, okay, I have data. I know how much iPhones I've sold in the US, how much I have sold in the UK, when I have sold most iPhones in the US, when I've sold most iPhones in the UK. But does Apple know that it can also unearth some other insights? Something like, what can be my prospective customers? When can I launch a new iPhone without cannibalizing the sales of my existing iPhone? What can my future sales be? So these are aspects of what a company or what an individual does not know, even though he or she or the organization as a whole has the data at hand. And then again, the last part comes of what we don't know that we don't know, right? We don't have the data for specific things and we don't know anything about that. So for example, data regarding its comparator sales. So Apple's is most competitive with a manufacturer like Samsung. who is the second largest handset manufacturer in the world. Apple does not know how many handsets, how many S10s or how many Note 9 Samsung has sold in July till date, right? So it doesn't know how their sales can compare to Samsung sales, right? So these things are classified as classic examples of business intelligence and data sciences, right? So what we know, what we can do with the data at hand, that falls under business intelligence. So through business intelligence, we know that, okay, we have sold this much phones in this location, we have sold this much phones in this location. Also, we don't know how much these guys have, these kind of phones have sold. Through data science, we can draw insights and we can try to understand that, okay, since we have sold this much data in this location in this period of time, 2 years down the line, we can expect to sell these many phones at this particular location at this particular time, right? So this is how data science helps in identifying certain business problems and try to resolve these business problems through data-driven and insight-driven solutions. Okay, I'll just stop for a bit. If you guys have any questions before we move on to the next slide.
Aritra, Jishnu here. Can you hear me?
Yeah.
Yeah. So Aritra, my question is like, by seeing the differences that you explained, can we conclude like data by using data science techniques, etc., we can achieve business intelligence like that? So data science is the reason we are getting business intelligence. Can we say that?
To a certain extent, yes. So see, business intelligence, data science does not seek to replace business intelligence. Data science only strives to improve the intelligence that we gather from the data that we have in the business.
Since I'm just giving one example, Aritra, like your third block, like you don't know what you know. So once you apply data science on your data, then you will actually know what you know. So it comes to the first slide.
Exactly. So data science seeks to improve the business intelligence process.
Right. That's what I'm saying. Yeah.
Yes, that's correct.
Okay.
Data science only seeks to improve the business intelligence processes that are already set up in the organizations. Good questions and very good inference from you. Okay. And any other questions?
No, I'm good, Aditra.
Okay. Anybody else? Okay. So moving on. In this particular slide, I'm trying to make you understand of the differences between the minute differences between a business intelligence process and a business intelligence process with data science incorporated in it. Now, business intelligence processes, they churn out business BI reports inside, and top executives, they basically look at what has happened before and based on their intuition, based on their experience, try to take business decisions so that their business can go forward. Data science, on the other hand, provide us with the capability of making business decisions through data-driven and insight-based findings. It enables us to properly mine our data, slice and dice our data, and unearth several aspects of information which business intelligence in itself cannot unearth. And that is how nowadays data science is enabling businesses to make factual-based, data-driven, insight-based decisions. Again, as we discussed in the previous slides, business intelligence answers questions like what happened, where it happened, when it happened, how much it happened, right? And data science, in addition to that, answers questions, business questions like why it happened, how it happened, and what can we do in future to ensure that this happening only goes for the better, goes for something better, right? Now, the structure of a business intelligence system in an organization is usually information management, that is the ETL process, building the data warehouse, to reporting what has happened in the past. What data science does is data science introduces another module in this process. In between information management and business reporting, data science digs deep into the data, mines the data, and generates certain insights which are then reported to the business. So the quality of reports, the quality of insights that you get out of a data science process is a whole lot better than what you would get from a legacy business intelligence process, right? Okay, moving on, let's see what are the life cycles of a data science project. So most of us over here I believe have a slight idea of what is the life cycle of a software engineering project, right? Now, let's see what is the life cycle of a data science project. Now, data science project, it starts with problem definition. So unless and until there is a problem, you will not know what to work on, right? You have to have a problem so that you can find a solution to it, right? So the first stage of the data science life cycle is identifying the problem, gathering in relevant information to the problem, understanding the business requirements, as to say that why this problem is there, what are the questions being asked in the business, and where exactly the problem lies. Right? The second stage is data exploration, exploring the options of from where we want to source the data to solve the problem. Now, usually a business intelligence setup or a data warehouse setup will have a lot of data stored in it, but we need to identify what kind of data we actually need to solve this problem. So to give you a small example, if a particular if a particular bank wants to build a credit risk model, it wants to identify which customers it wants to give loans to, approve loans for, and which customers are very risky to give loans to. Now they want to build a credit risk model out of it. So what kind of data will they have, or will they rather want? They will specifically want the past history of the customer, right? Is that so? Past credit history rather, just to check whether a particular customer has he or she, how good has he or she been while repaying their previous debts. Have they repaid their debts on time? Have they defaulted? Have their debts gone into bad debts, and so on? They are not at all interested in the customer's daily habits, like when does he wake up, where does he live, when does he go to work, when does he return, what is his likes and dislikes, what does he do on Facebook. They do not want any kind of such data for these customers, right? So next is the data preparation. Now, this is a very important stage because at times what happens is that the data that we collect, the data that we source has several anomalies, right? There may be several outliers to it. By outliers, I mean erroneous data. There may be several instances of data which is missing. So, and we need to treat these kinds of data, right? We need to ensure that whatever data we start working with is clean, is correct. Otherwise, the results that we will end up with might be erroneous. So we need to prepare the data properly. we need to standardize it. Say, what do I mean by standardization? Our data may have different kinds of units attached to them, right? So for example, age, if we have data at a user level, age will be in years. Then another user level attribute may be income may be in rupees. Then say we have may have data like gender may be a string, male or female. Now these have several different kinds of units attached to them, right? Years, rupees, and then a string. So we will want to standardize the data to a certain format so that the kind of data processing that we do is greatly enabled if the data is standardized. Again, another instance of data preparation is that there may be several missing data. So data might not have been captured. So somebody might not have, while entering, somebody might not have entered his age. They might not have wanted to reveal their gender. So these can be missing data points. If we have a lot of these missing data points, the insights that we draw may be erroneous. So we can either treat to ignore these data points, drop these data points which have a lot of missing value, or we may want to impute the some kind of data by taking average of age, or say taking whenever the gender is not there, we can decide to enter female or male as per our as per our wish, but as per the business requirements, right? And then we can arrive at a data set which is clean and ready for processing. Next is the most interesting part of the data science project, the one which all of us have heard a lot about, is the data modeling, statistical modeling. So in this particular stage, what we do is we try to model out the data by applying several statistical algorithms like machine learning, natural language processing, deep learning, reinforced learning, and all these kinds of like big buzzwords. And then we try to build a business rule saying that, okay, if a person has not defaulted once at all in while repaying his debts, if a person's annual income is say over 1 lakh per month, if a person's age is over say 40, his credit score is say something like very good. Or else if a person has defaulted less than 5 times while repaying his debts, and his average monthly salary is some say 50,000, and his age is between 30 to 40, he has a credit rating of good. If a person has defaulted say over 20 times, has age is between 30 to 40, average monthly income is somewhere say 30 to 40,000, his or her credit score is bad. So this is basically the rules that or the insights that we get out of building a statistical model or machine learning model. And then we need to validate our model. We just cannot test our data. So basically this is like the testing phase of any software developer's life cycle, right? We test our software, we test our models with one set of testing data, and then we introduce a whole new set of data to test whatever business rules we have built, or whatever model we have built is correct or not. So this is called the validation phase. Now after validation comes implementation of the models and maintenance of these models. Now this is basically slightly tricky, because implementing a model and into the production scenario is slightly different than how we implement a normal software into production. A model implementation depends on various category of items. It depends on how much risk a business is willing to take, because no model can give you an accuracy of 100%. There has to be some amount of error that flows into the model. If a model gives you 100% accuracy, that please be very aware that the model is incorrect, that your model is not at all correct. There can never be 100% accuracy on your model. So implementing a particular model actually is a decision which is taken by a data scientist and the business end users on how much risk are they willing to take. If a model is say at 70% accuracy, do they want to go ahead and implement that model in real life scenario to arrive at business decisions, or do they want to try and improve that model so that it reaches a higher accuracy level of, say, something around 75 to 80 or even 85%, right? And also another decision that business needs to take is that whether they want to implement a single model for a particular business use case, or they want to introduce an ensemble model wherein your business rules are defined by running several different kinds of algorithms or several different kinds of machine learning models on your data set. So one might be a regression model, one might be an SVM, support vector machine model, one might be a decision tree model. And all of these models will give you similar but slightly different outcomes. And then the business will basically take and amalgamate these rules, and they will say probably take an average of all these three kinds of outputs and finally build their final decision rules or the business rules. So this is called ensemble modeling, right? So again, implementation and maintenance, this is a phase which is taken by a decision which is taken by both the business users as well as data scientists. Now I'll pause for a bit over here and open the floor to any kinds of questions that anybody might have.
Aritra, could you please reiterate the last three phases on a high level again? Modeling, validation, and implementation maintenance. These three.
Sure.
In short, yeah.
Sure. So modeling is basically applying several statistical and even non-statistical techniques and methods to arrive at to basically draw insights. So for example, let's say that the example that we were discussing about, that a bank wants to build a credit risk model. So what we want to do over here is that we want to classify customers. We have the past history of the customers, how they have repaid their past debts, what is their age, what is their occupation, their gender, their annual income, say monthly income, whatever you like. And we want to classify whether these customers are have a good credit history or a average credit history or a bad credit history. So we will try to build several models. So this is the case where we will build a say decision tree model or a logistic regression model, which will basically classify the customers into three different type of buckets based on their attributes. What are the attributes? The attributes are his or her age, his or her past credit history or past payment activities, rather, his or her age, his or her gender, occupation, and so on. So as I told you, the outputs will look something like, if a person has never defaulted in any of their past payments, their age is say above 50 and have a monthly income of above 1 lakh, they may be bucketed into an excellent credit rating category. If they have defaulted say 5 to 10 times in their previous payment of debt, if their age is something less than, let's say, 30 to 40 and their annual income is 50 to 60,000, they may be bucketed into, say, average credit rating bucket, and so on, right? So this is how we build the model, right? And next, the validation phase is, again, we have tested. This is exactly similar to how we develop a software system, right? So we when we are developing something, we have our own set of data to test it, right? And then what do? We release this software, or we release this app that we built to several users. We pass it on to our friends and ask them to test this particular app on their smartphones to see if it's working over there or not. So a different user may have a different way of thinking. They might use the app differently. So we need to ensure that our app can cover his or her level of thinking as well. That's the exact thing that we are doing in the validation phase. We pass the model on to a different set of data points, right? A completely different set of data points which have different set of behaviors, different set of characteristics. And then we ensure that, okay, whatever buckets we had defined in our model building phase, they are more or less correct in the validation phase as well, right? And then once we are once we are sure that our model has attained a certain level of accuracy, we go on and push that model out to production. Now again, as I told you, the level of accuracy also depends on the level of risk that a business wants to take, or how much risk a business is willing to take. So a business might be slightly less adventurous and may not be willing to implement a model unless and until it has close to 90% efficiency. Or in other words, a business may be may have a greater appetite of risk, and they may be willing to implement a model into production scenario even if it has a 70% accuracy. Right? So does that answer your question?
Yeah, it does. Thank you.
Okay. We have another question in the chat from Debaritya. He's asking, so just like machine learning, the more the amount of perfect data, the more the accuracy of the data science model. See, perfect data does help in increasing the efficiency of the model, but we cannot truly say that if our data is perfect in every sense, our data science model or our machine learning model will be perfect. No, that is absolutely not true. As I told you, if you see that you have a very high percentage of accuracy, you should be afraid, because more often than not, if you have a very high level of accuracy, your data or your model, there are chances that your model has been overfit. That is, the data has been so perfectly cleansed, has been so perfectly tuned, that your model has actually overfit into it, and such a model will actually fail in the validation phase, right? So in the modeling phase, we should we should look at the accuracy level with a bit of skepticism, and rather we should look at the accuracy of our validation phase with more interest, because the data science models, the machine learning models are very data intensive, right? So we build these models after running through a lot of testing or with the test data set, or rather the development data set. So at times it happens that the models can get overfit, or the models are so fine-tuned that they explain the development data set perfectly, but they fail to explain the validation data set perfectly. So what should be our what we should emphasize more on is that we have a perfect split of data in the development data set and in the testing data set. That is, the development data set and the testing data set should cover a decent amount of variance that the data has, right? Okay, does that answer your question? Or okay, cool. Any other questions? Just wait for a couple of more minutes, a couple of more seconds rather. Okay, cool. So guys, okay, we have another question from Arun. Can we say modeling is a development stage? Yes, modeling does fall under the development phase. That's why where we develop the models, we build the algorithms, and then in the validation phase, we test it out. Right. So guys, we'll just take a couple of minutes break. And it's right now it's 11:23. Let's take a 5-minute break and let's start the last phase of today's discussion at somewhere around 11:30, 37. Uh, 11:37. Yes, that should be fine. Okay, guys, see you in a bit. Okay, guys, shall we start in another minute or so?
Yes, it's okay for me.
Okay, great. I'll just give others a minute to settle down, and then we'll proceed to the last phase of this discussion. Okay, guys, let's start then. Let's proceed to the last phase of our discussion for today. And in that phase, we will discuss who a data scientist is. So I hope everybody is in, or should we wait for another minute or so to so that everybody settles down? Shall I continue? Okay. Yeah. Before we start, we have a question from Dr. Prabhu. Can I do research in this area? What kind of problem I have to focus? Uh, can you elaborate on exactly what you are trying to ask, sir? Yes, research, data science is a research-based field. Uh, Definitely, there are lots and lots of research work going on in this field. Lots of new algorithms are being built. Lots of new ways to solve business problems are being tackled at a time. There are several programs, university programs, which offer a PhD in statistical modeling, statistics, or advanced mathematics, and machine learning. Yes, lots and lots of requirements are there for advanced researchers in the industry, advanced researchers in data science field. What kind of problem area you have to focus, that depends on the domain you are in. Say, for example, if you're working in a finance domain, say if you're working in a bank or an insurance sector or any kind of finance domain, your focus area will be different from that, the focus area in which a person working in, say, FMCG or technology field. So for a data scientist in finance domain, he or she will be more into risk modeling, reducing the risk of the business, because finance is an extremely stable and extremely sluggish field, and they are not they do not they do not want to disrupt their status quo. So they are more into how do I model out my risk, how do I reduce the amount of risk that I take, and so on. Other domains like fast moving consumer goods, technologies, they have more appetite to digest the risk, so they might need some other robust models to increase their sales, increase customer loyalty, and reduce the cost, and so on, right? So hope that answered your question. Moving on, who is a data scientist? uh, the definition in your screen is a classic definition which I've loved since the day one of my data science journey. A data scientist is someone who is better than in programming than a statistician, and better in statistics than a programmer, right? So basically, statistics and programming are polar opposites of each other, right? They are totally different fields, right? So a data scientist needs to be somewhere in between. He needs to understand mathematics, statistics, and also he needs to be pretty good at programming to develop those data science model, to develop those workflows, automation, and so on. Now, there's a small diagram which I want to share with you. This basically will throw a lot of light on what data science basically includes. So data science includes knowledge, high degree of knowledge in statistics and mathematics, high degree of knowledge in programming, which is represented here by the orange Venn diagram, the orange circle. It's called hacking skills, but don't take it in the other way. It means good amount of programming knowledge, and you would require a very good understanding of the domain in which you want to work in. So if you want to work in marketing, you need to understand the nuances of marketing. If you are working in finance, you need to understand each and every data element, because understanding the data, understanding the background of the data is very, very important in being to be a if you want to be a successful data scientist. Otherwise, you will not be able to distinguish between one kind of data and the other kind of data. So you may face issues like you have, say, 1,000 data points, 1,000 columns of data which you need to feed into your model, but you don't need 1,000 columns of data. You might need only, say, 50 columns of 50 data points, 50 columns of data. Now you need to have a very good knowledge of background knowledge, or knowledge of the domain, or the knowledge of the market, to identify that which columns I need and which are the columns which I do not need. Now, hence, a mixture of good knowledge in statistics and mathematics, along with good programming knowledge and expertise in the domain, leads to a good data scientist. Now, what all skills do you need to develop to become a data scientist? What skills does a data scientist have in his or her toolkit? First and foremost is the data mining skills. Now, as a data scientist, you will have access to a plethora of data. You will be basically sitting on a huge pile of data, and you will be asked to draw insights or pull valuable information from it. That is almost equivalent to finding a needle in a haystack, right? So you need to be very, very good in mining the data using SQL or any other big data technologies, so that you should have an eye for detail and those kind of things, so that even by looking at even by running a few small queries, you can catch the trend that the data is taking, right? Next, you should have very good storytelling skills. What do I mean by storytelling skills? You need to be able to represent your findings in ways that the business people can understand, right? And for that, we use, as data scientists, we use several data visualization tools, some like Tableau, ClickView, D3, Power BI, and so on. Next, you need to have very good programming skills. Programming skills are essential to build workflows, automating the current processes, building machine learning models, and everything. Currently in the market, there are two languages which are extensively used by data scientists: Python and R. These two are very, very powerful and robust languages. And Python has been there since before Java. Like Python has been there since the 60s or 70s, if I'm correct. Java has come into being only in the later 80s or 90s. But Python has existed way before that. And Python has developed into a very, very robust programming languages which can handle any kind of programming. It can handle designing your front end website. You can handle designing your middleware. It can even handle designing your back end data warehousing and your data workflow pipelines for your data science activities. So Python, and also again, to cap it off, Python is free. You don't have to pay a single penny for Python, and developers are working actively to introduce several newer and better and more robust libraries in languages like R and Python. So these are kind of evolving into a better programming languages each and every day. So next skill that a data scientist must have is statistics, a very good understanding of statistics and machine learning. Statistics basically will enable you to explore the data that you have at hand, understand what data points are useful, what data points are needed, what data points are not needed. And also statistics will enable you to interpret your machine learning outcomes, the results that your machine learning algorithms throw out at you. Last but not the least, a data scientist must have the ability to think analytically and the ability to solve problems by looking at them, or by like slicing and dicing the data at hand at a very early level. So basically you need to have that eagerness, and you need to have that zeal to solve business problems. You need to think that, okay, if there's a problem, I'm the man to solve it, right? So in a nutshell, these are the kinds of skills that a data scientist needs to develop in himself or herself to be a successful data scientist. Now, moving on, how does a data scientist use his or her skills in day-to-day life? Now, as I told you, the data mining skills are used to discover trends and patterns in the data. So you will be given with, you will be handed over like terabytes of data, and you will be asked to draw meaningful insights from it. And at times you will not even be told the business context. You will be just told that, okay, I have purchased data for say I have purchased data for mobile handsets for the last 5 years. I want to know what's going on in the market. That's all. That's all that you'll be told. And you need to mine the data, and you need to understand what the data is telling you and you will need to be able to draw insights from the data, discover trends and patterns in the data without even if you're not given any context. So that is the basic data mining skill that you need to develop. Next comes the statistics and machine learning skills. So statistics is needed for exploratory data analysis. That is if you remember the phase of a life cycle, in the life cycle of a data science project, we had a phase called the data preparation phase, right? Where we basically wrangle the data and we basically polished the data before we started building our machine learning models. Statistics is heavily used in this particular phase. In this particular phase, we explore the data. We do a EDA or exploratory data analysis to understand what the data actually is. So we need to understand how the correlation is between the data points, how much a data, how much the output variable will change if we change a particular input variable. If it has a positive correlation, say if we increase the value of a particular variable, will the output variable increase in value or decrease in value? That is to say, if it exhibits a positive correlation or negative correlation. Also, we try to explore what data points we actually want. If we have, say, a thousand data columns, we might not need all of them to build our machine learning models. We might need only 50 of them. So we need to check which which 50 of these columns actually very effectively or very effectively cover the entire variance of the data. Which 50 of these columns can explain the data set as a whole, and we do not need the remaining columns at all in our data model. Also, in this phase, we use statistics to identify the outliers and remove them. We use statistics to impute missing data points and so on. And machine learning, as you know, it's used in modeling the data, modeling the business rules. And again, statistics is used to interpret the output of our machine learning algorithms. Stuff like our machine learning throws us output in the form of accuracy output in the form of, say, R square or MAPE or MSE or these kind of things. So a basic understanding of statistics is needed to understand what is R square, what is adjusted R square, what is mean average error, what is mean percentage of error, all these kind of things. Right. Next, programming skills. As I told you, Python and R are heavily used in this industry, and they are used to automate and build the workflows, build the and develop the data science models, and so on. Now, the only work of a data scientist is not just to build models and to generate insights. Nowadays, in industries also expects data scientists to automate their day-to-day work. So, for example, if a particular organization needs data from one Excel sheet to be copied into a second Excel sheet by transforming the rows into columns, and then this particular data needs to be uploaded to a server, and then once this data is uploaded, a particular process will start. Now, organizations expect data scientists to create automated workflows which will handle all these kind of things. Now, this automation is usually done in Python and stuff like MATLAB or VBA, right? So basically, that's another item that data scientists need to do. They need to build robust data pipelines, robust and automated data pipelines. Right? Next, storytelling skill. This is probably one of the most important skill that a data scientist needs to develop. Storytelling, or rather data visualization, is extremely important because because as a data scientist, you are expected to present your findings or present the insights to the decision-making body, which is usually your board of you, which is usually your the business side users. So they will act accordingly on your insights. So if you just go up to them and tell them that, okay, I've built a model, I've used these many data points in development phase, I've tested the data model using these many data points in the testing phase, the average error is this, I have transformed one variable into squared one variable, I've taken logarithmic transformation, I've dropped 50 other variables because they do not contribute to the model, and the average error of the model is, say, 25%, so it's at 75% accuracy. All these kind of things will mean nothing to a business person, right? The business person will not know what R squared is. He will not understand what what is the difference between a regression model and a decision tree based model. He will not, he will not be interested in all these facts. He will just say, okay, you have built the model. What do you want us to do? What is your suggestion? What route should I take? So this is where your storytelling capability, or the ability to present your findings to someone who is a layman to these, comes into effect, right? So you need to explain clearly. Say, for example, let me take the example that we were discussing previously. A bank wants to build a credit risk model, right? So as a data scientist, you have built a very good model and your accuracy is say around 80%. So how you would need to present the model to the, how you would need to present your insights to the business. Now, as a part of the storytelling process, you will need to explain your business rules or the insights that you have drawn to arrive at these business rules. Say, what were our business rules? We had concluded that if a person has never defaulted in his any of his previous payments, is if his age is say greater than 50 and his monthly income is greater than 1 lakh, his credit rating will be very good. So exactly this is how you should formulate your findings and present them to the business, saying that okay sir, if you come across a person who satisfies all these criteria, you can mark that person as an excellent credit risk holder, and you can give a loan to that person, or you can issue a credit card to that person. However, if a person has defaulted say less than 5 times, and his age is between 30 and 40, and his average annual monthly income is say somewhere around 60 to 70,000, he is at a decent credit level, and uh, you may issue a loan to this person, or you may issue a credit card to this person, but you should cap your limit, or you should put a cap on your credit limit, or you should increase his rate of interest by this much amount, because he is not as good as the first person, right? So this is how you should represent your findings, or you should tell you should showcase your findings to the business, so that they can understand what steps they need to take based on your insights that you have drawn. Correct? Okay, and last and not the least, this is probably the most important skill that a data scientist should have, is the ability or the willingness to solve problems, to think analytically, to have the urge or to have this drive or motivation from within to solve any and every kind of business problem that the organization faces. Right? Because problems may come in a variety of shapes, sizes, and forms. Right? And you must have the aptitude or the eagerness, at least, a willingness to solve these business problems. Now, how does a data scientist benefit a business? First and foremost, a data scientist's insights can help a business predict what is going to happen in the future. So, for example, say I'm a handset manufacturer, say Apple, and I have the sales for iPhones for the last 5 years, and I ask my data scientist to tell me what will happen in the next 1 year or 2 years. So a data scientist will help Apple understand how much their sales is going to be in the next, say, 2 to 3 years. How will that help Apple? That will in turn help Apple to handle their inventory. So Apple will think that, okay, if I have 100 million in sales, if I am expecting 100 million iPhone units to be sold, I need to order 100 million of software of 100 million of chipsets from Qualcomm. I need to order 100 million of screens from Samsung, and I need to manage my inventory. I need to manage my workforce so that I am capable of producing at least 100 million of iPhones for the next 2 years. This is how
prediction helps, a data scientist helps a business in predicting what is going to happen in the future. Now, a data scientist also helps in deriving insights from the current data. Now, say, again, taking the example of Apple. Say Apple has launched a new phone, say iPhone XS is already launched, say iPhone XZ. And recently after launching iPhone XZ, they see that the sales of iPhone XR has reduced. Now, a data scientist can actually help them understand on whether the launch of a new handset, of a new product, can lead to cannibalism or can lead to reduced sales in its existing products or not. Say iPhone XZ had features similar to iPhone XR, and iPhone XZ was launched at a price which is slightly lower than the iPhone XR. So that will definitely lead to reduce in sales in iPhone XR, correct? So, but a business person, he is only looking at the end data. He's only looking at the sales. He will not understand why this has happened. Now, a data scientist can help a business user understand that why this has happened. If launching an existing product can lead to cannibalism of your, if launching a new product rather, can lead to cannibalism of your existing products or not. Next, data scientists help in business or an organization in understanding what the market scenario is, what their competitors are doing, and thereby gain a slight edge over the competitors. And also, as we just discussed, data scientist helps a business in taking very, very important business decisions. Right? Now, moving on to our last point of discussion, data scientist, you must have heard that it's currently the hottest job in the markets. I can go to the length of saying that it currently is the hottest job of the century. Now, why so? Why is a data scientist so popular, and why is it the hottest job role in the market right now? First and foremost is because there is a huge lack of highly skilled people who have a mastery in all the skill sets that we just discussed, starting from data mining, data storytelling, statistics, machine learning, programming, analytical thinking, and so on. There are very few people who have a mastery in all these skills. Next, organizations tend to overpay data scientists who have a mastery in all these fields because there's so high demand of data scientists. And also, data scientists opportunities are not limited to one or two domains. So for example, the work of a software developer might be restricted to only the IT sector, right? Or he may have very little exposure in other sectors, say core finance sector or manufacturing sector and so on. But data science is required across all the domains, all kinds of business, starting from IT, finance, banking, insurance among finance, then manufacturing, handset manufacturers, technology manufacturers, and startups. All of them, all these companies are currently sitting on a huge pile of data, and they need somebody to mine the data. Hence, data science opportunities, they exist across all forms and all kinds of domains. So that brings us to the end of this particular session. I hope you guys have really gained some kind of knowledge from this session. And now I open the floor to discussion and questions if you have any. There's already one question from Sangeeta. She's asking what the difference is between data mining and data science. Say, Sangeeta, data mining is the broader umbrella under which data science falls, actually. Now, what is mining? So in the raw term, mining is basically digging deep into the earth and looking for something precious, looking for something valuable or important, right? So data mining is basically looking into our data, digging deep into our data, getting our hands dirty and uncovering some truth, uncovering some trends or patterns or some insights that will help us in going forward. Data science falls under, is actually a category in data mining. Data mining basically uses uh, technologies like SQL, data visualization technologies, statistical methodologies, and machine learning, deep learning, and so on. However, data sciences, they are more focused on the statistical and model building. Hope that has answered your question. Guys, any other questions?
Hi, this is Ganesh here.
Hi, Ganesh.
Yeah, I do have some questions. Like one of my friend is working for one company in data science. Okay, so he's telling that he's working functional side of data scientist.
Okay.
So is there something called technical side and functional side in data science?
So data scientist is a techno-functional role. So as I told you, as a data scientist, you need to have good programming skills, good technical skills, as well as a very good understanding of your domain, right? So good understanding of your domain will actually help you in mining the data properly or building even more robust models. So that is where the functional part comes in. So yes, it's a technical functional role. Your friend, if your friend is working solely on the functional side, I'm not sure exactly what he meant by that, but yes, there is a functional part to data science as well. But it's not this only that you'll be needing to work on functional part. You'll need to have a good amount of technical exposure as well for a data scientist.
Yeah. So on this note, like I just asked him whether he's working in big data or not. So he's not working in big data part something. So he's working purely on ML actually.
Okay.
Yeah.
Yeah. So there comes the technical part, right? ML falls into the statistical modeling and the technical the technical portion. So yes, it's a techno-functional role. You need to have knowledge in both the domain. You'll have to have a domain expertise as well as technical.
Okay, that's fine. Thank you.
Okay. Others? Any questions? Okay, I'll wait for some more time. If any one of you have any questions regarding to today's what we have covered today.
Hello.
Yeah, hi.
Yeah, this is Ganesh here again.
Yeah, hi, Ganesh.
Yeah, since we have many algorithms in ML, right, for this. So in a market, like say for example, like LDA or something is there. So uh, all these kind of algorithms have been used repeatedly in market, or only few set of algorithms have been used repeatedly, since we have many
Yeah.
algorithms, right?
Okay. That's a good question. Actually, the kind of algorithm that you need to apply to solve a particular business problem actually depends on the business problem a lot. So ML has several parts to it. ML has supervised learning, unsupervised learning, reinforced learning, and then again we have deep learning, neural networks, all these kind of things. So it depends totally on the kind of business problem that you have at hand. So for example, if you want to solve, if you want to basically categorize what kind of products are similar. So for example, you are Amazon and you want to show a user similar kinds of products when he or she is browsing through your website. So for example, if I'm browsing for a DSLR camera, Amazon should show me other DSLR cameras, or say something related to a DSLR camera at least, and they should not show me something else like dresses and utensils and whatnot. So if your aim is to categorize products or group products into separate clusters, you may apply unsupervised learning, something like clustering. Or else, if your goal is to, say, build a credit risk model like we were doing in our example, that is basically again classifying certain users based on their attributes, you can use classification algorithms like logistic regression, multi-logic regression, decision tree, support vector machines. Again, if you if you want to predict your sales, or if you want to forecast your sales for the next year, say 5 years or so, so your output variable will be a numerical variable. At that time, you can apply something like a multilinear regression, which outputs numerical values. So basically, the kind of algorithm that you want to use would totally depend on the business problem that you have at hand.
Okay. Yeah, thank you.
Yeah, so we have one more question from Srinivas. He's asking, to become a data scientist, do we need to know or master machine learning, AI, and deep learning? Yes, machine learning is very important. AI and deep learning, they are good to have skills. AI and deep learning, they are, at the moment, the industry is not very well matured to implement stuff like AI and deep learning. Yes, there have been very few instances where the industry has stepped into AI and has stepped into deep learning, but most of them are still in the research phase. But yes, machine learning is being extensively used in the industry as of now, and the rise in machine learning basically has seen an exponential rise over the last few years, last 3 to 4 years. Right. Hope that answers your question. Any other questions, folks? Okay, I think there are no other questions. So we will end. Okay, we have another question. From Arun, if we are ready to study data science, what are the various learning opportunities? So there are several possible ways to learn data science. There are free materials available in the internet. There are videos in YouTube on how to become a data scientist, on excellent videos from Khan Academy and Udemy or Edureka on data science statistics. And there are also some paid options like Coursera, Udemy, and Great Lakes, online learning facilities like Edureka and Coursera is also there. These are all paid. And again, there are these are all online. There are classroom courses as well. One of the courses of which I was a part of was from the Indian School of Business, Hyderabad. They have a 1-year course in business analytics. Then several other courses exist as well. One from the IIM, IIM Kolkata, IIT Kolkata and ISI Kolkata. They together give a master's in business analytics degree. And again, last but not the least, we at Tamilboomi, we are also going to start an online training platform for data science. We'll share more information on that with you shortly. Okay. Okay. Any other questions? Okay, great. So we will end today's session here. Thank you everybody for joining this, taking the time out to join this session. It was a long session today. Thank you everybody for participating in discussions. It was a very lively crowd that we had, a very good audience. We had some really interesting questions and really good discussion. Thank you so again for joining, and I'll see you again tomorrow around the same time. Will share the link to tomorrow's session with you before the session starts. Till then, thank you everybody and have a nice day.
Thank you. Bye.
Yeah, thank you.